this website called askamathematician.com and see what they have to say. Question: if the Earth was flat, would there be a horizon? If so, what would it look like? If the Earth was flat and had infinite area, would that change the answer? Answered by a physicist: there'd definitely still be a horizon if the Earth were flat. In fact, mathematically, you can make the argument that a flat Earth acts the same as an infinitely big Earth. So basically what they're saying is the horizon on an infinite flat plane would work the exact same way as it does on a ball with the radius of 3,959 miles. You wouldn't be able to tell the difference. It works the exact same way. So let's begin by looking at this perspective diagram. As you can see, all these horizontal parallel lines all converge at the vanishing point on the horizon as they get further away from the observer. So the lines that are below us appear to go up in the frame as they get further away, and the lines that are above us appear to go down in the frame as they get further away. This is similar to what it would look like if you were looking down a long hallway. When you look at this picture of a hallway, we know that both the walls are parallel with one another. And we know that the floor and the ceiling are also parallel with each other. But our eyes do not see them that way. Our eyes converge them all at the horizon. So this is a first-person perspective. Okay, you are the observer in this picture. But let's take a look at what this would look like from a side angle. All the horizontal lines that are visually parallel, they all visually intersect at the horizon. Okay? So it forms a right triangle here, with the horizontal line being at eye level, and the hypotenuse is the ground. It appears to go up to the vanishing point, to the horizon, which is right here. So we know that all these horizontal lines converge at the horizon, and they will radiate out of the horizon. All these radiating lines are actually parallel, but our eyes don't see them that way. So a lot of these flat earth debunkers, they make side view illustrations that show these horizontal lines parallel, like this, when they should be making their illustrations like this. The higher up the horizontal parallel line, the steeper the angle at which it converges at the horizon. Okay? So notice how we have a red solid line as the ground. You can't see through the ground. The ground is a true limit. So these radiating lines here, they stop at the ground. But in an upwards direction, all these horizontal parallel lines radiating out of the horizon, they continue to go. There's no limit in an upward direction. That's why I've continued these lines. So the higher up the parallel horizontal line, the steeper it converges at the horizon, at the vanishing point. Now we know all the horizontal lines converge at the horizon, including the ground. Now I've continued the ground in this illustration so that I can make a point. Because if these lines are all converging after the horizon, let's pretend like they diverge, right? Theoretically. So I've continued the ground. Now if there was a boat sailing away from Cash, when it's closer, he's going to be looking slightly down to see it. And as it gets further away, he needs to look a little further up, and a little further up, and then a little further up. When the boat gets the same distance away from the observer as the distance to the horizon is, Cash will be looking 0 degrees, completely horizontal and parallel with the ground. He'll be looking straight ahead. Now what if the boat gets a further distance away from the observer than the distance to the horizon? What if the boat got to here? Well, now Cash would have to look in an upwards direction to see something that we know is below him. It's not possible. It doesn't work. Now you can only see the face of the ground up until your horizon. You can't see the face of the ground past the horizon. Okay? Cash can't see the ground from here to here, but he can see things that are above the ground for a little bit past the horizon. That's another function. The higher an object is above the ground, the further you can see it past the horizon, but you can't see the ground past the horizon. So if the boat was a little bit past the horizon, but had about 10, 20 feet of height on these sails, this is what Cash would see. Now if the boat got even further away, Cash would have to look at an even greater upwards angle to see something that is below him. And at this point, that ship's not even possible to see. This is what Cash would see. Nothing. It's past the horizon. The horizon is a set distance away.